Welcome to the Deep Dive. Today we've got a really compelling stack of sources. It challenges that whole modern narrative that science and faith have to be at war with each other. This material argues that scientific discovery actually provides compelling evidence for a creator.
And that's the core tension we're diving into, right? I think a lot of people just assume that science automatically leads to secularism, but the sources we've looked at argue the total opposite.
So our mission here is to really understand that argument. Looking just at the source material, we're going to unpack its claims across, I guess, three main pillars.
Right.
First, the cosmology of the universe's origin. Then there's this concept of fine-tuning that allows for life. And finally, the just staggering complexity we find in biology itself.
And we should probably just jump in with the hook right away because it's genuinely surprising. For the pioneers of science, the whole quest for knowledge was, well, it was explicitly linked to their faith.
It's so fascinating. I mean, when you look back at the people who essentially invented modern science, they weren't trying to disprove God. They thought they were, trying to understand his blueprint.
Exactly.
You have Johannes Kepler, for instance, who framed his entire life's work by saying that science is thinking God's thoughts after him.
I love that quote. It positions the scientist not as some kind of antagonist, but as a privileged explorer who's reading a manual written by an intelligent author. It really sets the tone for everything else.
And for them, the deeper they looked, the more ordered and intentional the cosmos seemed to be.
Yeah, and that feeling didn't just stop in the 17th century. The sources also bring up Louis Pasteur, a titan of microbiology.
Of course.
He had this observation. He said, "A little science takes you away from God, but a lot of science brings you back to him."
And Lord Kelvin, with thermodynamics, he had a similar idea.
He did. He said, the more thoroughly science is studied, the further does it take us from anything comparable to atheism. And these historical points, they really confront this modern idea that skepticism is like the default for a rigorous scientific mind.
Okay, so let's unpack that central claim from the sources, that Christianity specifically made the very idea of science possible. That sounds, well, pretty radical.
It does, but the argument hinges entirely on one concept.
Right.
Rationality. The sources claim that the whole foundation of science, the fact that there are universal laws of physics, that math is repeatable, that biology has predictable systems, all of it points to a logical, consistent creator.
So the logic is, if you believe a rational God made the universe, you'd expect to find rational laws. But if you think it's all just random chance, why would you even look for consistency?
That's precisely the argument the source material makes. The belief in a lawgiver is what gave early scientists the confidence to even look for consistent laws in the first place. You see it in figures like Isaac Newton. His work was built on this premise that the cosmos followed universal, established rules.
So it was less of a philosophical belief and more of a working hypothesis for them.
Exactly. For Kepler, for Robert Boyle in chemistry, their work required this deep conviction that the universe was governed by fixed laws that God had set in motion. It's what made their experiments meaningful. Otherwise, every result would just be a random toss-up.
Then the sources shift a bit. They make this interesting claim that the evidence itself isn't supposed to be hidden or obscure. It's actually meant to be obvious.
They use very strong language there. The material draws on theological texts, citing things like Psalm 19, the heavens declare the glory of God.
And also Romans 1, which they interpret as saying that God's invisible qualities have been clearly seen since creation just by looking at what has been made.
Right. And the conclusion they draw is that the evidence is plain. And because it's plain, people who ignore it are without excuse. Now, for you listening, that language can be challenging, but the sources are setting this up as the foundation for their scientific arguments. They're basically saying the evidence is so clear it should be self-evident.
Okay, that brings us to the biggest picture possible, cosmology. How do the sources tackle that huge question? Why is there something rather than nothing?
This is where they bring in a really old philosophical tool, the Kalam cosmological argument. It directly challenges the idea that the universe could just be eternal or pop into existence from literally nothing without any cause.
I mean, that's a problem for everyone, right? Theists, atheists, you have to explain where matter and energy came from. But the sources say the idea of a universe emerging from no thing, uncaused, it just defies logic.
It does. So they break the Kalam argument down into three simple steps. First, everything that begins to exist has a cause. That's, a basic scientific and philosophical axiom.
Okay, that makes sense. Step 2 is where modern science really comes into play. The claim is that the universe began to exist. How do they back that up scientifically?
They point to things like the expansion of the universe, which implies a starting point, what we call the Big Bang, and they lean heavily on the second law of thermodynamics, right? Entropy. Usable energy in a closed system always decreases. So if the universe were infinitely old, it would have run out of gas by now. It would be in a state of heat death. But since it's still hot and active, it must have had a beginning.
So it can't be eternal. It had to start somewhere, which leads to step 3.
Which is the logical conclusion. Therefore, the universe has a cause, and this cause has to be powerful enough to explain the massive effect it produced.
Okay, so here's the philosophical leap. How do the sources justify that this cause must be, timeless and immaterial? Why not just some other physical thing we haven't discovered yet?
That's a great question. The argument is that since this cause brought time, space, and matter into existence, the cause itself has to be outside of those things. It has to transcend them.
Because if it were physical, it would need its own cause.
Exactly, you'd get stuck in an infinite regress, which they argue is impossible. So a being that is outside of time, space, and matter. Well, they claim that aligns perfectly with the characteristics of the God described in the Bible.
And they tie this back to the idea of laws, that the laws of physics themselves imply a lawgiver.
Yeah, I mean, if the universe were truly random, why would gravity work the same way here as it does in a galaxy billions of light years away? The stability, the order of it all, they argue, that requires an intelligent, sustaining force.
This is where it gets really compelling for me. We're moving from the universe's beginning to its incredible precision. Let's talk about the fine-tuning paradox.
This is often seen as the strongest scientific argument in the source material. It's all about the specific values of the constants of nature. Things like gravity, the strong nuclear force that holds atoms together, electromagnetism.
And the sources really stress that for life to exist, these values have to be in these ridiculously narrow ranges.
Unbelievably narrow. For example, if gravity were just a tiny bit weaker, matter never would have clumped together into stars and galaxies. A tiny bit stronger, and the universe would have collapsed back on itself almost instantly. Either way, no life.
No us.
No us. The odds of all these constants just happening to fall into the life-permitting zone by pure chance is where the argument gets its real statistical power.
The sources use that classic analogy to explain just how improbable it is.
They do. The tornado in a junkyard assembling a Boeing 747. The idea that this perfect precision happened by accident is, well, they call it statistically illogical. But they don't just stick to analogies, they bring in the math.
And the number from physicist Roger Penrose is the one that it just stops you in your tracks.
It really does. Penrose calculated the odds of our universe's low entropy state, the specific state needed for any kind of complex structure to form happening by chance. The number is 1 in 10 to the power of 10 to the power of 123.
I mean, let's just pause on that. That's not 10 with 123 zeros.
No. It's a tower of powers. It's an exponent with 123 zeros. To give you some context, the total number of atoms in the entire observable universe is estimated to be about 10 to the 80th power.
Which is already a huge number.
A tiny number by comparison. The scale of Penrose's figure is so vast, the sources argue it just moves the idea of chance completely into the realm of statistical impossibility.
So if the macro universe is that improbable, let's trade the telescope for a microscope. What does the source material say about life at the cellular level?
The focus shifts to information. The argument is that life is built on an information system that just defies any kind of unguided construction. They describe DNA not just as a bunch of molecules, but as a code of staggering complexity, a language.
And like any language, the letters have to be in a specific order to mean anything. A random jumble is just noise.
Precisely. A specific sequence means something. A random one means nothing. And the sheer density and complexity of this genetic language in every single one of your cells, they argue, points to an intelligence far beyond our own.
The sources also highlight something more recent, which makes it even more complex. This idea of epigenetic information. Can you break that down for us?
Yeah, so think of DNA as the script for a massive play. Epigenetics is. It's all the director's notes. It's the lighting cues, the stage directions. It doesn't change the words in the script, but it governs how the script is used, which genes get turned on, which get turned off.
So the whole other layer of information about the information.
It is. It's like a cellular operating system controlling the raw data and trying to explain how this multi-layered functional language just appeared through random chance. The material asserts that's scientifically untenable.
So what are the actual odds they cite? They call the chances of spontaneous generation statistically absurd.
The numbers are, again, just astronomical. The odds of the right chemical building blocks randomly forming just a single functional protein are estimated at 1 in 10 to the power of 164.
That's essentially zero.
It's effectively zero. And that's for one protein. A basic living cell needs hundreds, sometimes thousands of them, all working together. The probability of a simple cell forming by chance is estimated at 1 in 10 to the 40,000th power. So the source concludes that any explanation for life's origin that relies only on unguided random chemistry is invalid. The numbers are just too high to overcome.
This overwhelming improbability brings us to the final 2 points in the material. First, this paradox with the SETI program.
Yeah, this is a fascinating point about contradictory logic. Scientists in the search for extraterrestrial intelligence, SETI, are looking for simple, ordered patterns in signals from space.
Like a sequence of prime numbers, for example.
Exactly, like 2, 3, 5, 7, 11. And if they found a signal like that, the entire scientific community would, without any debate, call it proof of alien intelligence.
Of course, because that kind of order doesn't happen randomly. A simple pattern implies intent.
Right. And yet the source asks, why do those same scientists often dismiss the vastly more sophisticated information-rich code in DNA, this complex biological language, as just the product of random chance?
That is the inconsistency they're pointing to.
It's the core of it. They're willing to see intelligence in a simple radio signal, but not in the functional, self-replicating information code found in every living thing on Earth. The question they pose is, why are we so eager to find a hypothetical intelligence out there, but so quick to dismiss the evidence for it right here in our own biology?
And the second critique is aimed at Darwinian evolution. They make a key distinction here.
They do. They separate microevolution from macroevolution. They state that microevolution is a documented fact, small changes within a species like bacteria developing antibiotic resistance.
We see that happen.
We do. But the source material raises serious doubts about macroevolution, which is the idea of one species transitioning into a fundamentally different kind of species over vast amounts of time.
And what's their argument against that?
The core claim is that the fossil record just doesn't show it. It offers very few and highly debated examples of the transitional forms you would expect to see. If life evolved gradually, they say, the proof should be literally set in stone by now, but it hasn't happened. They argue the fossil record shows abrupt appearance and then stability, not gradual change.
So ultimately, they conclude that Darwinian evolution is just an insufficient explanation for life.
Yes. They say it fails to explain the very first step, how life arose from non-living matter to begin with, and that the sheer complexity of integrated systems, like the human eye or a bacterial flagellum, can't be explained by random mutations and natural selection alone. All the parts have to be there at once for it to work.
We've covered a lot of profound ground today in this deep dive. We started with the historical compatibility between faith and science.
Then we moved into cosmology, with a column argument for a necessary cause, backed up by modern science.
And we looked at that incredible precision, the fine-tuning of physical constants, and the intelligent, complex code embedded in our own DNA.
And if you connect it all back, the sources present this powerful, statistically driven case that the universe isn't just finely tuned for us, but that it appears to be divinely engineered.
So after all that, what's the big takeaway? What should you, the listener, be considering as we wrap this up?
I think the final provocative thought based on this material is this. When you are faced with statistical probabilities for the existence of life that are just overwhelmingly small, 1 in 10 to the 10 to the 123rd for the universe, 1 in 10 to the 40,000th for a single cell, is it more rational to conclude that a lawgiver intentionally set the rules for this highly ordered system, or that those rules just happen to be accidentally perfect? That question